This is going to be part one of work and power. You're going to need to take notes in your notebook, but some of this information is already either in your formula chart or in your definition key term page. So you do need to write down the information you need as we go. Most of this you're already going to find in your definitions and formula charts, but the important thing to notice here, work is equal to force times distance. What do these little symbols mean? From math, you know those little symbols mean parallel. This is the really important thing. When we're talking about work, the force has to be parallel to the distance that we're moving the object or it doesn't count. We'll see that in a second. Also, the SI units for work are joules, which is a J, and it's just equal to newtons times meters. So if my force is in newtons and my distance is in meters, my work is going to come out in joules. I don't have to do any special conversions. So pause the video a second and copy this question down. Just pause it, write this down. Okay, now that you've written this down, we're going to do this problem. A student lifts a 50-pound ball 4 feet in 5 seconds. So the force is going up and down, my distance is going up and down, so those are parallel. Here's how we do it. Write your formula down. I know it's a short formula, write it down. Plug in what we know, 50 pounds, 4 foot. Multiply on your calculator. Notice this came out in foot-pounds. That's the same units we had when we did torque. This is how we end up with torque, foot-pounds, force times distance. However, our problem asks us to give it in joules, and this is in English units. So now we're going to convert over. This is still the same problem, we're just going to convert to joules. So we're going to look up each one of our conversions on the conversion chart. Pounds, we can use this conversion to get to newtons, and feet, we can use this conversion to get to meters. Go look it up on your conversion chart. Make sure you can find this and you know how to do this step yourself. Pause if you need. Okay, now I'm just going to go back to my formula, work equals force times distance, and plug in these right here. And when I do this multiplication, it automatically, Newton meters automatically comes out in joules. All right, here's our two formulas for power. And there are two different formulas. It can be either energy divided by time or work divided by time. Both energy and work are measured in joules, and so power ends up being measured in joules per second. Here's our same problem we had earlier. Now write down this question. How many watts of power did the student use to lift the ball? So same scenario, another question to go with it. Write it down. Well, work, we already figured out, was 271 joules. We did that earlier. So to figure out power, we just take work divided by time. So here's our work, there's our time, divide, and we get joules per second. Write all this out, including the formula. Joules per second is watts. You don't have to do any other conversions, it just is. Okay, efficiency. You heard a little bit about efficiency when we did simple machines, but now we're going to actually convert. Efficiency has to do with when we lose part of our energy. For instance, if we have friction, some of our energy is not going to end up in our output and it's not going to be 100% efficient because some of it goes to friction. If we're talking about electrical energy, like in a light bulb, we lose some of our energy to heat. When we lose energy, we have less than 100% efficiency. So to calculate the efficiency, we just have either the energy out or the power out divided by the energy in. Notice if I have the same units on top and bottom, this efficiency will not have any units. It's just going to be percentage. So now I'm going to pause the video and then we'll go to part 2 and we'll work this problem.